Welcome to Maths Classes 7-8 CBSE by GK Pillai. Students and parents, you must be hearing about fractions for a long time and must be having some idea about fractions. But there is much beyond that. This video on the chapter Working with Fractions of Class 7th, based on the new syllabus of NCERT, will explain you much more about fractions. Every important portion of the chapter from the textbook is explained in an easily understandable manner. Subscribing to my channel will be a morale booster for me, so please subscribe and press the like button. More videos for classes 7th and 8th will be uploaded shortly. Fraction. The definition goes this way. A fraction is a number representing part of a whole. The whole may be a single object or a group of objects. Here there is an example. 3 by 7 is obtained when we divide a whole into 7 equal parts and take 3 parts. Here you can see the whole is divided into 7 equal parts. Out of that, the red portion is the 3 parts taken out of it. So that is why a fraction is a number representing part of a whole. The whole thing is 7 and the part is 3. For 1 by 8, we divide a whole into 8 equal parts and take 1 part out of 8. That's all about the simple definition of fractions. For 3 by 7, we say it is 3/7. And 3 is the numerator and 7 is the denominator. Here you will see some examples of how fractions are formed under various situations. What fraction of a day is 8 hours? A day has 24 hours, so the required fraction will be 8 upon 24. When reduced, it will be 1 by 3. What fraction of an hour is 40 minutes? 1 hour means 60 minutes and the fraction will be 40 upon 60. Reduced, it will be 2 by 3. Another one, write natural numbers from 2 to 12. What fraction of them are prime numbers? So the natural numbers between 2 and 12 are 3, 5 onwards till 11. And the prime numbers are 3, 5, 7 and 11. So the required fraction will be 4 upon 9, because there are 9 natural numbers between 2 and 12 and the prime numbers are 4. So the 4 upon 9 will be the required fraction. There are many terms associated with fractions. The first one is proper fraction. A proper fraction is a fraction that represents a part of a whole. In a proper fraction, the numerator is always less than the denominator. This is an example. These are the examples of proper fraction. Here, the numerator will be always less than the denominator. Improper fraction. An improper fraction is a combination of whole and a proper fraction. In an improper fraction, the numerator is bigger than the denominator. You can see the examples. 7 upon 2, 12 by 7, 18 by 5, etc. I'll explain you after discussing this one. Mixed fraction. A mixed fraction is also a combination of whole and a part. Here, the whole is 1 and this is a part, 1 by 4. When you combine these two, you get improper fraction only. When you take it 1 into 4, 4, 4 plus 1, 5, 5 by 4. This will be 2 into 7. 14 plus 3, 17 by 7. This is the way we get improper fractions. Improper fractions can be converted into a mixed fraction also. The next one, converting improper fraction into mixed fraction. This is what I was about to discuss in the previous page. Improper fraction can be expressed as a mixed fraction by dividing the numerator by denominator to obtain the quotient and the remainder. Here 13 by 5, divide the numerator by 5 you will get 2 and the remainder will be 3. You write 3 by 5. This is the way once again 7 by 4 can be converted into a mixed fraction. The next one, like and unlike fractions. The fractions with the same denominators are called like fractions, and the denominators are different, then they are called unlike fractions. These are examples of like fractions, 3 by 7, 5 by 7, etc. Unlike fractions, 3 by 10, 5 by 13, etc. Equivalent fractions. Fractions where the shares are equal are called equivalent fractions. You may be confused about this definition. I'll explain you from here, you will understand it. Fractions where the shares are equal are called equivalent fractions. 1 by 5, 2 by 10, 3 by 15, up to even 10 by 50 are equivalent fractions. How you get? Multiply both the numerator and the denominator of the given fraction by the same number. For example, 1 by 5, you just multiply by 2 by 2. Numerator as well as denominator, you multiply by 2, you will get 2 by 10. If you multiply by 3, you will get 3 by 15. If you multiply by 10, the numerator as well as denominator, you will get 10 upon 50. So by multiplying the numerator and the denominator by the same number, you will get equivalent fraction. The same way, divide both the numerator and denominator by the same number, you will once again get equivalent fraction. For example, 10 by 50, if you divide the numerator as well as denominator by 10, you will get back 1 by 5. So these are all examples of equivalent fractions. Now, a short way to check whether the two fractions are equivalent fractions. You just cross multiply the 2. 3 by 5 equal to 9 by 15. 9 into 5, 45. 3 into 15 is also 45. So these two are definitely equivalent fractions. Now, the simplest form of a fraction. A fraction is said to be in the simplest or lowest form if its numerator and denominator have no common factor except 1. Here 2 by 3 is an example. Between 2 and 3 there is no common factor other than 1. So 36 upon 54 we are having a fraction. Both are even numbers, so we decided to divide by 2. When divided by 2, the numerator as well as denominator, we get 18 upon 27. Once again, 18 and 27 have the highest common factor of 9. So we can once again divide the numerator as well as denominator by 9 to get 2 by 3. But one thing let me tell you, here we divided first by 2 and then by 9. It is not necessary. If you can identify 18 to be the highest common factor between 36 and 54, you can cancel them and get the simplest form of the fraction 2 by 3. So that is what is mentioned here. The shortest way to find the equivalent fraction in the simplest form is to find the HCF of the numerator as well as denominator and then divide both of them by the HCF. So here 18 is the highest common factor. Here comparing like and unlike fractions. You can see the two examples given here. 2 by 7 and 2 by 11. The numerators are same. Here 10 by 7 and 15 by 7. The denominators are same. So how it will turn out when you are comparing these two? If the numerator is the same in two fractions, then the fraction with the smaller denominator is greater of the two. So 2 by 7 is greater than 2 by 11. Even though the numerators are same, but 7 is smaller than 11, therefore 2 by 7 is greater than 2 by 11. Now it will be the opposite way here. If the denominators are same, the larger numerator will be the greater one. If the denominator is the same in two fractions, the fraction with the larger number is greater than the greater of the two. So 15 by 7 is greater than 10 by 7. Now another one, when we compare two unlike fractions, we first get their equivalent fractions with the same denominator. There is an example 3 by 4 and 5 by 6. First we will find out the LCM of 4 and 6, 12. So we will make the denominators of 3 by 4 as well as 5 by 6 same. For that we will multiply the numerator and denominator here by 3 so that you get 9 by 12 as the equivalent fraction. In this case you are multiplying the numerator as well as denominator by 2 so that you get the denominator as 12. Here it is 9 by 12 and here it is 10 by 12. Naturally 10 by 12 will be greater than 9 by 12. Therefore 5 by 6 is greater than 3 by 4. When you just see these two numbers, two fractions, you won't be able to decide which one is greater and which one is smaller. Only by taking the LCM and making the denominator same, we will be able to compare two unlike fractions like this. Addition and subtraction of fractions was part of your previous syllabus. But just to recall, I am just giving some examples. These things you will be able to understand. I am not discussing it. Now let us come to this one. Adding 5 by 6 to 3 by 8. The LCM of 6 and 8 is 24. We will make the denominator same. We will multiply 5 by 6 by 4, the numerator as well as denominator by 4. And in the case of 3 by 8, we will multiply by 3 and 3. So we are getting 20 by 24 and 9 by 24. When you add them, you are getting 29 upon 24 and you can write as a mixed fraction here. Now subtracting 3 by 4 from 5 by 6. Once again the LCM of 4 and 6 is 12. So 5 by 6 minus 3 by 4 means we will make both the denominator same by multiplying the first one by 2 by 2 and the next one by 3 by 3. We are getting 10 by 12 and 9 by 12 and final answer will be 1 by 12. The next one here 3 by 5 and 7 by 20. So the LCM of 5 and 20 is 20 only. So we are making this denominator same as 20. Multiply the numerator and denominator by 4. You are getting 12 by 20 and 7 by 20. When subtracted you will get 5 by 20 and you can reduce it 1 by 4. These are very simple sums only. You have got many difficult sums of adding and subtracting. I may be including it in my future video on the chapter. Now the next one, multiplication of fractions. Your present syllabus is about multiplication and division of fractions only. This is a general formula for multiplying two fractions. If a upon b and c upon d are two fractions, then a upon b into c upon d will be the product of the two fractions. Once again, you will be able to write it as a into c upon b into d. Here I am giving an example. 7 upon 11, if you are multiplying by 5 by 8, you can write it as 7 into 5 upon 11 into 8. That will be 35 upon 88. Let me tell you one more thing. If you are having a upon b into c upon d equal to this, even if you write this one as c upon d into a upon b, it doesn't matter. Both are one and same thing. Now, there are two terms associated with multiplication of fractions, multiplier and multiplicand. When we multiply 3 by 5 by 4, 3 by 5 is called the multiplier and 4 is called the multiplicand. You must have studied about fractions earlier also, but this is the first time we are using two separate words to identify these two. The first one is multiplier and the second one is multiplicand. Now here I am giving another two examples where the multiplier or multiplicand is a whole number. 7 into 3 by 5, you can write 7 as 7 upon 1. So it becomes a normal fraction. Now you multiply as I told you here. 2 by 7 into 11, write 11 as 11 upon 1. Then you multiply the way we are discussed here. So your answer will be 22 by 7. And here it will be 21 upon 5. Multiplication of fractions, simplifying to lowest form. This is a very important part. When you will be required to do sums, definitely one occasion or the other, you will have to do this kind of things. Multiplying fractions and expressing the product in the lowest form. For example, 15 by 16 into 4 by 25. Now instead of multiplying 15 into 4 and 16 into 25 and then cancelling the things, straight away you can do it here. You can write it as 15 upon 16 into 4 by 25. Now you can decide this way. 4 and 16 can be cancelled to get 4 here. Here you may write 1. 15 and 25, they have got a common factor of 5. When you cancel 15 by 5 or divide 15 by 5, you will get 3. 25 when you divide by 5, you will get 5. So you can cancel these two. We use the word cancelling. Cancel these two and get 3 and 5. Now you can multiply the numerators and denominators to get the final answer. So we divide the numerators and denominator with the common factors and then multiply the numerators and the denominators. This is called cancelling the common factors. Multiplication of fractions is explained in the textbook with the help of a unit square and the area of rectangles within that particular square. I will be discussing only this sum in that particular way. Rest of the sums will be done in the direct route only. Here in the figure, if we start with a unit square of side 1 unit, here there's a square of side 1 unit. The length and breadth of the shaded rectangle will be 1 by 2 unit and 1 by 4 unit respectively. How it can be? If this is considered as 1 unit, this will be half of it. And this is again 1 unit, so this will be 1/4 only. Area of each of the 8 such rectangles having fractional sides. Why we are saying fractional sides? We are actually explaining the product of fractions. So area of each of the 8 such rectangles having fractional sides as its length and breadth is equal to the product of the two fractions. That is 1 by 2 into 1 by 4, 1 by 8. This is a general thing. The product of the two fractions is equal to the area of the rectangle formed with the two fractions as its sides. There is no much practical purpose for this. Here you will find two sums to explain how the fractions are multiplied. These are very simple sums, just to make you understand only these two arguments. And difficult sums you will definitely find in the next video. A person on cycle covers 1 by 5 kilometers in 1 hour. How far can he cycle in 3 hours? Distance covered in 1 hour, 1 by 5 kilometers. In 3 hours, multiply by 3, you will get 3 upon 5. In the textbook, it is explained this way also. 3 into 1 by 5 means you can add 1 by 5 3 times. You will get 3 by 5. Since the denominators are same, you will add the numerators only like this. Find the area of a rectangle of sides 3 by 4 feet and 9 3 by 5 feet. So this will be the length and this will be the breadth. So length of the rectangle will be 9 3 by 5 feet and the breadth 3 by 4 and the area will be L into B. You will multiply these two. First we have to change it into a improper fraction. 9 5s are 45 plus 3 48 upon 5 and 15 by 4 this one will be there. And you can cancel out 5 and 15. You will get 3. 4 and 48 when you cancel you will get 12. 12 3s are 36 square units. You have to cancel. The relationship between the numbers multiplied and the product. Numbers include natural numbers also and fractions. We are discussing it in two columns, multiplication and relationship. Both the numbers are greater than 1. This we have been doing These are the natural numbers. The product is greater than both the numbers. 5 into 6, 30. Both the numbers are between 0 and 1. The product will be less than both the numbers. If you multiply 3 by 8 into 4 by 5, after cancelling out the common factors, you will get 3 by 10. This 3 by 10 will be surely less than both of these fractions. Here, one number is between 0 and 1 and the other one greater than 1. When you multiply such numbers, the product will be less than the number which is greater than 1 and greater than the number between 0 and 1. 5 by 7 is between 0 and 1 and 3 is the number greater than 1. When you multiply whatever you are getting 15 by 7, this will be less than 3, but greater than 5 by 7. That is what is explained here. Now we are going for division of fractions. This is also explained with the help of a formula. Division of one fraction by another is equivalent to multiplication of the first fraction by the reciprocal of the second. A by B, when you are dividing by C by D, you can definitely multiply the first one by the reciprocal of the second. A by B into D by C. A into D upon B into C. Example, 4 by 7 divided by 3 by 5 is equivalent to 4 by 7 into 5 by 3. Now if there is something to cancel out, cancel. Otherwise you can straight away multiply 4 into 5 and 7 into 3 and write as the fraction. Now the next one, 3 by 10 divided by 5 1 by 6. You should definitely write this one as the improper fraction. From the mixed fraction you change it into improper fraction. 5 6 are 30, 31 upon 6. Now you have to multiply these two. Where possible we can cancel out, and finally you will get 9 upon 151. The next one, dividend, divisor and quotient. Normally when you deal with the natural numbers or whole numbers, we find these kind of terms when you divide one number by another number. But as far as the fractions are concerned, also we deal with these terms. When we divide a whole number by a fraction, the quotient is greater than the dividend. 6 is a whole number or a natural number. When you are dividing this by a fraction, the quotient which you are getting 24 is greater than the dividend 6. When we divide a smaller fraction by a bigger fraction, 1 by 8 is less than 1 by 4. When you are dividing the smaller fraction by a larger fraction, the quotient will be greater than the dividend. In this case, 1 by 8 multiplied by 4 by 1, you are getting 1 by 2, which is greater than the dividend in this case, greater than 1 by 8. And the third one, when we divide a fraction by a whole number, the opposite of this, then the quotient will be less than the dividend. 1 by 4, when you are dividing by 6, you are getting 1 by 4 into 1 by 6. This will become reciprocal, 1 by 6. You are getting 1 by 24. This is much less than the dividend of 1 by 4. This sum is related to division of fractions. But before discussing the sum, let me tell you one thing. For the classes other than 10th, whatever the teacher has taught you in the classroom is definitely important. So along with the contents of my video, you should ensure practicing the sums which have been discussed by the teacher in the classroom, because you may get questions in the class test or even in the final exam from those particular sums. The sum is, for covering an area of 7.5 square units with square bricks of sides 1 by 4 unit, how many such square bricks are needed? Area of each of the brick will be 1 by 4 into 1 by 4, 1 by 16 square units, side into side. and the area to be covered will be 7.5 square units. Change it into improper fraction. Number of bricks needed will be total area divided by area of each brick. 15 upon 2 divided by 1 by 16. When you reciprocate and multiply and cancel out wherever needed, you will get 120 bricks. Now, that is the end of my present video. Don't forget to subscribe to my channel and recommend my videos to others also.